Hello, good morning. Okay, we're going to start with the conference, Nexus Water-Energy Solutions Towards Sustainable Development Goals. This is part of a series of conferences that we have been doing as the opening of the second version of the International Congress of Biorefineries and Renewable Energy supported by ICT, to be held between the 17th and the 20th of February 2020 in Bucaramanga City, and is organized by the National Head of Engineering Research of the Universidad Cooperativa de Colombia under my direction. Okay, we send a special greetings to all those who are connected through the Zoom platform. Also, allow me, or I would like to greet also our panelists, Sid Vollebregt, General Manager of Elemental Water Makers, and Johnny Meit, who work as a financial controller of Oceans of Energy in Netherlands. These two companies are partners of the UCC, of our university, within the SWEET project that has been sponsored by the Dutch government through the Partner for Water scheme. Before starting with the presentation, we invite you to tell about this through your social networks, okay? For this, you can use also the numeral or the hashtag Verstic 2020. In this conference, we have a space or a room of 15 minutes for each of the presenters and a small room for questions at the end. This can be done through the chat on our platform, okay? You can write in Spanish if you wish, and then I can translate, the question to Sid and Johnny. Okay, we begin now with the first presentation, okay, coming from Sid Vollebregt, okay, who will speak about sustainable clean water using sea and sun. Okay, before giving Sid the floor, I would like to introduce briefly our guest. Mr. Vollebregt holds a master's degree at the University of Technology in Delft, the Netherlands, in sustainable energy technology and technological entrepreneurship. He has a passion for innovating international developments in the field of water and renewable energy. Mr. Vollebregt is involved in determining the company strategy, commercial developments, and project management, and has won several pitch awards. He has a strong vision that desalination driven by renewable energy holds an essential role for global freshwater supply. He is a water enthusiast, full of energy, and enjoys spending his free time surfing in the sea, sun, and wind. Elemental Water Makers provides complete reverse osmosis system driven by solar, wind, and or wave energy to enable affordable fresh water on site. Their solutions solve freshwater scarcity while only using the sea, sun, air, and wind. Many thanks to Mr. Vollebregt, for his presentation. Okay, and you can start now, Sid. Thank you very much.
Thank you for that wonderful introduction, Fernando. Good morning, everybody. Would it be possible to stop sharing the screen and I'll get to my presentation? So I'm talking to you from the Netherlands in The Hague, for the people who are interested. Let me see if I can share my screen now. All right. So, do you see my screen, Fernando? With the kids? Yeah, perfect. Let's go. So I'm gonna start my presentation with a little story about myself, a little background information, because a long time ago I went on a surf trip, on a holiday to Madagascar, and I'm wondering if perhaps any one of you ever been to Madagascar, or maybe you've seen the animated movie Madagascar, and that animated movie doesn't really resemble the real Madagascar. Actually, Madagascar, the country, is one of the 10 least developed countries in the world. And as I was making my way there from the capital of Antananarivo to the coastal city of Tutiara, I took this picture. And on this picture, you can see a couple of young boys that crafted some vehicles to carry water for their families. At that moment, I stopped the car and I tested and I tasted this water in those jerry cans. And yeah, this water wasn't really potable. It's not drinkable. It's salty. It's brackish. It doesn't meet the World Health standards for drinking water. But for these boys and for their families, they basically have no other choice. Water for them literally means life, and is the reason why they cannot attend any schools. So a couple of hours later, I found myself drifting on my surfboard under the abundance of the sun in this vast ocean. And that's where I realized that these unlimited resources of the sea and the sun, they should be part of a solution for water scarcity. And that's the moment that I specialized my engineering degree on water treatment and sustainable energy technology at the University of Technology Delft. And I became an engineer, specialized in this subject. And in 2012, I started the company Elemental Water Makers. And Elemental Water Makers, I'm going to tell you a little bit more about our activities now. We ensure fresh water today without limiting tomorrow by turning seawater into clean water using renewable energy resources from the sun or the wind or the wave energy. But let's first take a look at what does water mean in our daily lives. So we might not realize, but the water that we use in our houses or on our universities, the water that we use when taking a shower or drinking, this is only 1% of all the water we use. Most of the water we use is through the food that we consume. That's called our water footprint. For example, if we drink a coffee, that single coffee needs 5 liters to grow the beans to get your coffee cup. So we need a lot of water for food, we need a lot of water for energy, and we need a lot of water for products. So although we might not realize it, water for us, just as much as for these boys in Madagascar, also means life. And in that sense, I have quite an inconvenient message for you to share today, because there's already 4 billion people, that's 2/3 of the world population, that's currently facing water scarcity. And you can see on the map, there's a large region in Africa, in the Middle East, in Asia and Australia, but also Latin America and the Caribbean and North America are very vulnerable to the increase of water scarcity. And to me, this is the biggest challenge for humanity for the 21st century, because the difficulty is that the problem is growing. And of course, you're all very curious to see how the situation is in Colombia. And I found these pictures from the National Statistic of Water. And you can see on the left side, you can see an average year where water is short. And you can see, especially on the north coastline, for example, in Cartagena, Barranquilla, Santa Marta, La Guajira, there's a lot of vulnerable places for water scarcity. So also in Colombia, this is becoming a bigger and a bigger problem. And to cope with the problem, first we of course have to understand the problem. So how did we get here? Well, first of all, we are with more and more people, which means of course that we need more and more water for all those people, not to drink, but also for their food, for their energy, and for their products. So right now, the water footprint of all the inhabitants of Earth, right now we are using 3.5 times all the water that is available, which basically puts pressure on our natural reserves of the water. And because of that, we have lost over half of the wetlands in the past decades. And you can see that groundwater levels in many regions are dropping and dropping. And then of course there's climate change. Climate change, changing weather, causing droughts that last longer, but also when it rains really heavy, really strong, and the earth is unable to capture this water. So these days, unfortunately, it's not a question if there's going to be a drought this summer, it's more the question who's next. And this year, currently, there's enormous droughts in India, in Australia, there's droughts even in the Netherlands and in Europe. We have droughts in Latin America and in the Caribbean, but also again in California. So it's becoming a bigger and a bigger global issue. But fortunately for us, the good news is that if we look at the surface of the Earth, 70% of it is covered by water. So there's a lot of water. The problem is that most of this water is salty seawater, 97%, only 3% of our water is fresh. So as a water engineer, if I look at these numbers, the key to me to get access to more water lies in the sea. And this process is called desalination. And desalination, it's nothing new. It's been done for decades. If you go, for example, to an island like Aruba or Curacao, you will find that all of the water they use is desalinated. Also in San Andres, there's a lot of desalination. But desalination is very expensive because it uses a lot of energy. And if energy becomes expensive, then of course your water becomes expensive as well. But also the energy used for desalination comes from fossil fuels, which means that we actually contribute to climate change while we're actually trying to fight water scarcity. We're making it worse by this. So we find ourselves in a vicious circle. And then lastly, it's technology that is considered as complex, difficult to maintain, and only suitable to be used on small scale applications. Well, these are the three barriers that my company has been studying with the ambition to overcome them, basically. So we ask ourselves, how can we get fresh water today without limiting tomorrow? And I have a little video here, but I think the audio is not shared. So I'll send you the link later so you can watch it yourself. But that video basically shows a little bit more about the projects that we implemented and our value proposition, which is, so basically our technology couples existing desalination technology with existing renewable energy technology, but then we implemented some extra energy efficient energy recovery technology in it, which we developed, which makes us use less energy for the water. So what we can do is we can provide water for 70% lower than the conventional desalination. It's used only sustainable resources, so only the sun, so no more fossil fuels. The water is produced in a reliable manner, but because you can imagine if you're living on an island or you're staying at a resort or you're working at an industry, then you don't want to be without water any moment. And it's very important also that the technology is easy to operate and maintain, because most of our projects are in very remote areas. I just came back from a project in Madagascar a couple of months ago, and there, for example, it takes 36 hours to reach the nearest city. So you don't want to have difficult spare parts or difficult technology because the local people have to be able to operate and maintain the system themselves. So we do this through remote monitoring, through automation, and by using durable components that are very strongly protected, for example, against corrosion, which is a big challenge in this industry of saltwater. So we use, for example, duplex or super duplex steel to avoid any corrosion and avoid any maintenance with automation. And that has brought us over the past 5-6 years as we've been doing this, has brought us in many areas of the world. As you can see, these are some of the projects that we've finished. Currently, we're operational in 14 different locations. So this is a little bit old map. We're currently also executing a project in Chile, and we expect that soon we will also, together with the UCC and Oceans of Energy, are going to execute projects in Colombia as well, which is of course the reason why we're all here today. So about the technology, there's 3 different options if you're looking for water from the sea, which is really our focus. So we focus on regions that have no more freshwater resources, because desalination, it's a necessity. You only do it if you have to. If you have freshwater resources, you are fine. But if you don't, you can turn to the sea to get more access to water. So coastal regions next to the sea that have high energy prices could benefit from this technology. So let me take you through the 3 options we offer. The first one is, for example, if you have electricity available. So if you find yourself in Santa Marta, for example, and you run a hotel that is next to the ocean, and right now you're paying the trucks to bring you water, and you pay them like 10,000 pesos for a cubic meter, and you can make water for less than half of that yourself using this device. So this device is able to generate 11,000 liters per day, and it uses only 2.2 kilowatt hours per cubic meter of water. And for your understanding, if you use conventional desalination, this number is between 7 and 10. So it uses at least 3 times less energy. And that, of course, enables you much cheaper water. This unit has an automated fresh flush. So if it stands still, there's some fresh water that is being flushed through the membranes, making sure that the membrane lifetime is maximized. There's remote monitoring included, and it's really easy to operate just with a single button use. So if you look at the economics here, you can see a comparison between a standard reverse osmosis unit and an efficient one. And you can see that your operational expenses are much lower because of the lower energy expenses, which leads to much lower water prices. So we're at around $2 for a cubic meter. And that can be done for 1, for 10, or for 100 cubic meters per day. So how this technology works, I also wanted to show you a video. I think actually without the sound, it might be, let me explain it to you. So all the required energy comes from the sun. The amount of energy that we need is reduced by 75% by using energy recovery technology. This technology uses the residual energy from the saltier brine flow, leaving the reverse osmosis membrane. This means we can do with 4 times less solar panels. So it's just by using waste energy more efficiently that we can reuse this energy and need less energy. And for example, in Belize, on the most private island in the world, you can get access to this kind of water, but you do have to fly a helicopter to get there. So you might need to save up some money. Then this solution is a totally off-grid solution. So this one is very interesting for communities that both don't have water and don't have energy. It's standalone. For example, this unit here is in the Philippines, and such a single kiosk can desalinate up to 5,000 liters of drinking water from the sea using only those 12 solar panels, which means it could feed a population of 2,500 people with a singular water kiosk like that. And the water price is also below $3 US for 1,000 liters of drinking water, which is quite affordable. So we train the people to operate and maintain the system, and then distribute the water using those jerry cans you see just in front of the container. And if you do have energy, you can also double the energy, the water production by coupling it to the grid at night. And it is plug and play. So you just bring the container there, you open it up, and then you just need access to the sea, and it can start working. This is one in the Philippines. And yeah, this is the third one. It's as an engineer most interesting, but it might be too heavy to explain. Reverse osmosis uses pressure, and what we do here is that we store pressure by pumping seawater to a hill. So during the day we use solar energy to pump up seawater to a hill, and at night we use the same seawater to operate the reverse osmosis unit 24 hours per day. So we only have the sun, but we make water 24 hours per day using only gravity. And because there's no energy conversion losses in the system, it is a very good energy performance. But the downside is that you do need elevation. So you do need access to 90 meters or 290 feet, which is 80% less than you needed originally, because also here we developed this energy recovery technology. So for example, this one is in the Virgin Islands, and it has survived the impact of the hurricane of Irma. And that work hasn't gone unnoticed. So this was 2 years ago. I'm the guy on the right, not on the middle. And we were flown in by the ruler of Dubai to receive the Mohammed bin Rashid Al Maktoum Global Water Award. And we were chosen out of 138 organizations in this field of desalination by renewable energy. And we went home with the first prize of all those people. So that was quite the credibility. So the adventure started from the chieftains, from the boys in Madagascar, and of course there's still a lot of work to do, which is also why we're here today talking to you, because we're looking to work together with different end users of water, but also, for example, contractors and constructors of solar panels, foundations that do good work in remote communities. And we can look into providing water as a service for larger projects as well. Because for us, at the end of the day, it's the goal to get water for all, for communities, for resorts, for private properties, for utilities, for industries, and any other water user that might benefit from this technology. So if we look at Colombia, we already see there's 391 municipalities that are susceptible to running out of water. Those are the dark ones. And the challenge here is the number of these municipalities is also increasing. And as you can see, because we're looking at coastal applications for desalination, especially in the north it seems like there's a lot of opportunity and a lot of work that we can do. So we identified these kind of regions that we view could benefit from the abundance of the sunshine, and of course the seawater that is basically unlimitedly available, because there's too many trucks that are driving around in these regions that only displace the problems, that only fill the streets, that only add to the fossil fuel exhaust and pollute the air. While at the same time, if they use the sea and the sun, they can get access to cheaper water without all these negative impacts. For example, San Andres, same story. There's a lot of expensive water being charged only on I think the coverage of the island is 60% by the water network, so the rest gets its water by trucks. So also here, there's a lot of savings possible for different end users. But even in remote regions like La Guajira, the water is such a challenge that the development of the lives of the Wayuu people might be limited, affects their health, and also limits the availability to grow food. And with the climate change also affecting these regions, we believe that it's time to do something. And we're looking together with the UCC and with Oceans of Energy to formulate projects in these regions to help these coastal communities to get access to clean water from these unlimited resources. So in short, for today, as a takeaway is that it is possible to use these abundant resources. The technology is mature and available. It can make water at a lower rate. It only uses the solar energy. So if there are people interested in such a technology, please feel free to reach out to me, and let's solve freshwater scarcity together. So join us in solving freshwater scarcity using only the sea, the sun, earth, and wind. Thank you very much.
Thank you very much, Sid, for the nice presentation. Okay, so I just putting some, making some translation of the question into English. Okay, but this is going to be addressed at the end of the Johnny presentation. Okay, so Johnny, are you there?
Yes.
Okay, thank you very much. I just wanted to check, you know, if you hear us. Okay, I would like to mention briefly. Okay, many thanks, Sid, again for your nice presentation. Now we continue with the presentation of Mr. Johnny Meit, Financial Controller of the company Oceans of Energy. I would like to mention briefly his profile. Johnny graduated in Energy Science, Utrecht University, and Business Administration, University of Amsterdam, and was previously active at clean tech venture capitalist Yellow and Blue. He is responsible for planning, implementation, managing, and running of all the finance activities. Many thanks to Mr. Meit for his contribution. And at this moment, we open the room for you. Yeah, and please start with your presentation, Johnny.
Thank you, Fernando, for the nice introduction. Yes. So thank you all for attending this webinar. My name is Johnny Meit. I represent Oceans of Energy. With Oceans of Energy, we noticed that it's very, very difficult for countries, regions, coastal areas to get beyond 10% of clean energy in their energy profiles. So it's very easy to get the first steps done with solar energy, with wind energy, but it becomes very difficult to go beyond 10%. Especially key to this challenge to go further than 10% is the lack of physical space to put solar modules or wind turbines on. In our coastal areas, more than 50% of the world population lives there, and there are very densely populated regions that are sometimes even remote, and where it's very difficult to put the solar infrastructure on land, because first of all, the land is being used. Secondly, the land is expensive. And thirdly, the land that is available, we can use it for other goods, things that like a lot, such as nature, forests, or football fields. That's why it causes often a lot of public opposition to go beyond the first steps with renewable energies. The solution we provide is that we enable solar energy projects to be developed at open sea. We move the solar modules instead of building them on land. We build them in the vast area of the sea where plenty of space is available. Our systems are designed to withstand all of the ocean forces. This includes waves of up to 30 meters and the salt environment and all of the wind, hurricane forces, any kind of force. We are the only organization in the world that is focusing on applying these solutions to open sea. That's what we call offshore approach. It's our belief that renewable energy is always more successful in case it is provided at costs that are lower than the current power cost. We see that a lot of places where our offshore solar floating modules can be placed are currently supplied by expensive diesel generators. Our solution is already competitive with these diesel generators. We have designed our solutions for 25 years design life. They have been tested in the offshore basin test of the Marin with up to 30 meters wave height, which shows that they can even withstand hurricane conditions. We use mainstream commercial solar panels. So these are the same ones that you see in other projects. However, we put a structure around them that allows them to withstand the sea forces. We expect that our product has a higher power yield than onshore solar. The reason for that is that solar modules tend to heat up and lose efficiency on land. And at the sea, we expect it to heat up less. Also, we can develop projects that are very small, of 100 kilowatt peaks, and we can expand them to gigawatt peaks and even larger. So any size of project, it's like Lego, it's possible. And our systems are environmentally friendly. We know that they can stimulate the biodiversity by developing artificial reefs. And also we allow for synergies such as with aquaculture, marine farming, or reef restorations. It is our aim to, when we develop very large projects, that we can manufacture them in country to also allow the local economy to profit from these technologies. Synergies that we see include the floating artificial reef, which means that if you put platforms in the ocean, then other life will attach to it and grow to it, and an whole ecosystem can emerge. Below our platforms, there are possibilities for aquaculture and also for accelerated reef restoration through mineral accretion technology. In the project suite, in which we work together with the UCC and elemental water makers, we aim for reverse osmosis water desalination, so that our system can be used to supply the elemental water makers desalination units with the energy required. By doing so, we can create unlimited drinking water and irrigation water. Also, this water can also be used to produce ice, which can be very valuable, for example, for the fishing industry. Our key entry market is the islands in the world. So we see that over 35,000 islands in the world are inhabited, and predominantly they use diesel-generated power. Diesel generators are expensive because they're, first of all, not that efficient. Secondly, often not that well maintained. And thirdly, it's very expensive to transport the diesel fuel to these very remote islands and locations. However, at the same time, it's very difficult for these islands to change as of the spatial limitations. Often they can be, for example, very touristic, or they can be full of rainforests. It would be very difficult to cut rainforests or remove the touristic aesthetics by putting solar modules on land. If we look at the Caribbean, we actually see that it's a very, very promising area for our solution, as it's a very densely populated sub-region, and the average electricity supply costs are above the world average and even above costs of the remote Pacific. This means that there's a lot of money being lost currently with the diesel generators in these smaller islands. However, it's very difficult to change because of the spatial restrictions. If we look more closely in Colombia, we have the island of San Andres, which is a small island, but it has a very large population and high energy demand as of the tourist interest. And if we would want to provide it with 100% clean energy, you would need 150 megawatts of solar energy. For such, 1.5 square kilometers of area is required, which is about 20 to 25 football fields of space. This space is not available at this island. The current power costs are very high, and this also results in very high water costs. The government, the central Colombian government, pays yearly $25 million US dollars to subsidize the power, the energy generation costs. This is 40% of the overall budget for subsidies regarding energy generation in Colombia. With our project, we want to reduce the cost of clean drinking water and provide 100% of energy demand with cost-effective clean energy. This is the project suite that we have mentioned. And to the right, you see a brief sketch of how a system would look like. It is our ambition to be able to develop solutions that produce unlimited fresh water from the desalination, powered with the floating solar modules that are at sea, possibly out of sight, and that is applicable at any coast and at any scale. And such a solution would lead to 20 plus years of future-proof water supply that's not affected by climate change, and therefore a great additional value for like the current water systems. At the same time, it requires a minimum amount of land use as the solar infrastructure is at sea. With the suite project, we aim to provide very large solutions for cities like Santa Marta, Barranquilla, Turbo, and any kind of large coastal community in the Caribbean, including as well the other Caribbean islands. However, to develop this, we first need to approach it from an innovation perspective. Therefore, we propose to develop a suite pilot project, in which we would develop a water desalination unit that can provide water to about 5,000 people at a cost that is above current cost of desalination because of the additional innovation of the floating solar modules, but is still competitive with current costs that are currently being paid by the current water systems in some locations. Also, key to this pilot project is that we include environmental monitoring of the systems, which allows for policy and future permitting development in Colombia. So by showcasing it on a small pilot scale, we want to show Colombia that we can develop it on a safe and very large scale. And then we can develop our production facilities in Colombia, which could lead to very large price competitive projects in the big urban cities in the Caribbean. We also see opportunities to combine this pilot project with a microgrid, in which we would, for example, supply a small island next to with water, also with energy, or seawater ice and refreshment ice production, in which we would use the energy as well to produce ice for the island. And as well, we see opportunities for accelerated reef restoration, in which we can support coral growth. We aim for these type of projects currently at 5 locations, which include the Magdalena province with Santa Marta and Pueblo Viejo, the Gulf of Urabá with Turbo, San Andres Island, Islote del Santa Cruz, and finally the La Guajira region. We are currently conducting the feasibility study in these 5 regions. And as a result, we aim to develop this year 2 or 3 concrete proposals for this sweet pilot project. Then we will need to find funding for these solutions. And when this is secured, we hope to plan to build and operate our first pilot in Colombia in 2020, after which multiple Caribbean projects can follow and a large expansion can go throughout Latin America and the Caribbean region. In summary, Oceans of Energy, we provide a solution that allows for unlimited space for clean energy. And that is especially important for island nations and coastal regions. We can integrate our energy together with reverse osmosis to alleviate water shortages. Our solutions are already competitive with diesel-generated power, and in the future we expect them to be cheaper than all other energy sources. Our solution has no negative environmental impact, and instead we see a lot of opportunities to accelerate biodiversity increase. Our solution is 100% in-country can become 100% in-country manufactured, and we also foresee opportunities to enrich the local economy through marine farming. This was my presentation. Thank you for your attention, and let's go to the Q&A.
Okay, Johnny, many thanks for your contribution. Okay, so now we're gonna have, the question for you guys. Okay, some of the people are writing, the question on the chat. I already asked Sid, to check the questions that are addressed to him, but also for you, Johnny. Okay, but before that, okay, I would like to remind you that we would like to extend, the invitation for the PERSTIC Congress in Bucaramanga in February 2020, where we're going to have Johnny and Sid as well presenting the projects that they are developing, and also our project suite that has been developed with the university, with the UCC, okay? So also you can send the research paper to the website that we have for this Congress, okay? So the deadline for this is a very short paper, for maximum 5 pages, okay? The deadline is until August 31st of this year, okay? So thank you very much for that. So I don't know, Sid, have you had the opportunity to check the questions? Or you want me to read for?
Yeah, let me get back to some of the questions. I think the first one.
Okay.
First one is, what is the operating principle of desalination by osmosis?
Yeah.
In other words, how does it work? Well, it works basically just like a sieve. So if you can imagine that there's a sieve, and you put seawater under a lot of pressure on this sieve. It's like a spaghetti, and then only the small water molecules, they can travel through this sieve. Everything that is larger than an H2O molecule, which include salts, which include bacteria, which include viruses, iron, manganese, arsine, almost everything doesn't go through these small holes, which basically means that the water that you produce by putting this pressure on this sieve is really pure. That's why you also remineralize the water to add natural available minerals like magnesium and calcium for drinking water purposes. So that is in principle the operating principle of reverse osmosis. So it's filtration on a really small spectrum. So it starts with let's say microfiltration, then nanofiltration, and then reverse osmosis, which is really on a small scale. Then I think the second question, can we also provide energy by the osmosis principle? Well, you could generate energy from if you have a freshwater body and a saltwater body next to each other. They're actually because we have some salt water close to the fresh water. I think a project is called Red Stack. So red as in the color and stack as in a stack of something. So you could Google that and read a little bit more about the work that they're trying to do. In my opinion, it's not so feasible and scalable, but it's an early stage of R&D technology. The next question is, can you please repeat what conditions someone must meet to participate in the project? I think I'll leave that to Professor Fernando to answer. And then the latest two questions is the first, the problems that this project may lead to the future, since it can lead to a massive consumption and imbalance of environmental conditions. I think I don't really understand the question, because we're trying to create a balance of the environmental conditions by having no negative impact on the environment, not to use fossil fuels, to use not fresh water, which is limited, but seawater, which is very unlimited. So what sustainability looks like in this project is, by avoiding any negative impact on our environment. And the thoughts about the future with the ineffectiveness of solar panels with respect to climate change is that I don't foresee a future in which solar panels will get more ineffective. I believe they only get more effective by research, but also by cooling from the sea. In this particular project, the efficiency of the solar panel actually increases because the panels don't get so warm because they're cooled by the sea. So with that, I hope to have answered most of the questions, and I give the word to Johnny, who can continue the questions from the Oceans of Energy.
Thank you, Sid. So Johnny, you got one question in here. What material is the flotation surface?
Thank you for your question. The material that we use for our floaters, that is actually confidential. So I unfortunately cannot share that. Then the second question that I found was, how does the tide affect the panels? Thinking on the permanent movement. At Oceans of Energy, we have a lot of experience from the offshore industry, and we use common practices for mooring and anchoring systems that make sure that the platforms will remain stationary at their spot, and they can also deal with the tides that are present in Colombia.
Johnny, are you there? Can you hear me?
Yes, I can hear you.
Yeah, Johnny, there is another question. Where can I find more information about the pilot in Turbo? So also you can ask me later on about it. We are in the process of characterizing the region. So we're going to have more information about the pilot, but probably next year. Okay. So I guess that there are no more questions. Guys, thank you very much for that. So yes. So I don't know if you want to comment something else, or it's okay with that.
No, I think I want to thank everybody for their time and by joining.
Okay,
and,
we make enough time. Thank you very much. For more information, you can write to us at investigacion.ingeniería@campusucc.edu.co. You can also follow us on social networks, Facebook, as Jefatura Nacional de Investigación en Ingeniería, as well in Twitter, okay? This is at VerstickUCC, okay? We end this conference by inviting you to be aware of the next conference that is going to happen next month about biorefineries and bioenergy, okay? We're going to send the information. That conference is also going to be in English, okay? Yeah, and will be moderated by myself, okay? Have a wonderful day, and thank you very much, guys, for your attendance.
Thank you all. Have a good day.
Goodbye then.